So, thanks for having me here at the MTPC. My name is Patrik Schaub from FMS Internet Service in Germany, and I'd like to talk to you today about auto-configuration and advanced monitoring of MikroTik devices. My agenda is a short company presentation, the motivation for today's topic, explain to you the tools that we have available in MikroTik and the third-party tools that we will need to accomplish the examples that I want to show you in the second part of the presentation. FMS is a value-added distributor focusing on networking equipment and especially on ISPs, where we provide most access technologies that are available by today. And value-added for us means that we are also offering services around our products, so we are not a typical box-moving company. We've been founded in the late 90s and are situated in the southern part of Germany. We've quite a long history with MikroTik, as probably many of you, as I see many familiar faces. By today, we're the oldest active MikroTik distributor. We've been within the first international trainers. My trainer number is 23, although, well, I'm damned to live a company owner's life based by excellent PowerPoint, so I'm not giving trainings that much. But my colleague Sebastian, he's trainer number 11, he will have a presentation tomorrow. But today we've 4 certified consultants and we got like 60 to 70 years of experience in MikroTik for our customers. We had the honor to run almost any kind of project with MikroTik. What you see here on the picture is one of the largest ferry wheels in the US. We're working for the company who is installing the lights there, but we had projects in mining, airports, cruise vessels, military flight simulators, you simply name it. But we're especially interested in large networks, and this is like bringing us to the topic of my presentation today. Where will you find a large network? Of course, at the ISPs, and those networks can easily reach hundreds of thousands of devices if you're including the endpoints. But there are also big networks in IoT or machine-to-machine communication, which is a growing field where we see MikroTik a lot. You have municipals and also, of course, enterprise networks with potentially thousands of remote workers connected by VPN to their VPN access concentrators. And we see that it needs some additional experience and tools since large networks have their own challenges. We're offering a pre-staging environment, for example, where we pre-configure MikroTik devices to be zero touchable for our customers, and we ship around 10,000 devices per year pre-configured to our customers' needs. And we also have some experience in designing large networks. What you can see here is a screenshot of our largest CapsMan installation, or let's say the largest installation that we are running for one of our customers, and it has more than 1,000 access points. When we contacted MikroTik support with a certain issue, after some discussion we received the answer, Caps Manager is not made for that big installations. So that's what I mean with special experience in large networks. We got it to work at the end, it's running smoothly since 2 years, but even the vendor sometimes doesn't know how to use his own equipment in special circumstances. And we have some knowledge about operating those networks for our customers or together with our customers. And that's why I'm running this presentation. So why should you care about auto-configuration, monitoring, and visualization? There are some challenges that have to be accomplished in bigger networks. You want a fast implementation, and the internet service providers always care for time to market. They want to deploy a certain region before the competition does. You can offer better service quality if you have the right tools in place and will improve the security of your network. The best example here is if a security issue for a CPE gets to known and you have thousands of CPEs to be patched, it's different if you have to do that by hand or if you have tools in place that will do that automatically. And of course, you have less resources that are needed for operation and for deployment. as well in cost as also in manpower. And by today, manpower is often the limiting factor that you have as an internet service provider. And of course, there's scalability. If you have the right tools in place, it doesn't matter if you deploy one area or 2 or 3 area with 1,000 or 10,000 devices. So what tools do we have available within MikroTik, and what extra tools do we need to accomplish proper auto configuration and monitoring and visualization? You all know SNMP, so it's not necessary to talk too much about it. The simple network management protocol, which is supported by almost any NMS system on the market. Then there is TRO69. It's a bit more exclusive to the ISP market. TRO69 is a protocol made for configuring and updating CPE devices. And of course, there's the RPE, the API from MikroTik, and the REST API, which is a binding part between third-party devices and your router. The list wouldn't be complete without naming traffic flow, syslog, and the discovery protocols, of course, but I'm not going to talk about these within the presentation. Sad but true, there are also things we don't have available. For example, netconf young. netconf young is a more modern approach in carrier-grade equipment, often used in software-defined networks when you have intent-based configuration in larger network infrastructures. And there is no TR369, which is the successor of 069, and which has not yet been implemented in MikroTik. We'll see a couple of third-party tools, or we will need third-party tools to accomplish what I want to show you in the examples. An NMS, a network monitoring system, and an ACS. An ACS is an auto configuration server used for TRO69 protocol, which is able to configure and patch your CPE devices. Let's have a short look on how to set up these tools on your router, so we are prepared to go to the examples. For SNMP, there's not too much to say. Go ahead, use version 3 to be on the safe side and have a secure SNMP implementation, and you might want to set an individual engine ID. This is not done by MikroTik as a default, since all devices are coming with the same engine ID, and this might well confuse your NMS system. MikroTik's MIP, the management information base, the database with all the items that you can pull, is not very extensive, so there are quite a few questions that you cannot answer by using SNMP. And MikroTik is only supporting a few traps. Traps are like an active way the device can inform the NMS about certain circumstances. As I said, it's rather straightforward. Simply enable SNMP and create a community. And within the community, you have to make up your mind what security type you will use, if it will be private or authorized. Authorized means you only have authorization but no encryption. Private means you have authorization and that your SNMP traffic is encrypted as well. Depending on what you choose, you have to choose the proper authentication and encryption protocols and set the passwords, of course. This is the engine ID, which I showed or told you 2 slides away. On the left-hand side, you see the standard engine ID, which has been set by MikroTik, but it's suggested to have an individual engine ID for each device, and you could, for example, use one of these scripts to set an individual engine ID either by the serial number for hardware devices or the system ID for software devices like CHRs. Let's go ahead to the application programming interface of MikroTik. I would always use the REST API, the REST implementation, and you should keep in mind that SNMP is more efficient than REST is. So whenever you can pull an item by SNMP, I would prefer that. Setting up REST is easy. You need a web server on your router. Better use SSL here and set up the certificates, as you can see in figure 2. And it's wise to create a special user for the API and set up credentials for that user. If you only plan to have read access, limit that user or limit the user group to only be readable, just to have additional security. Once you did that, you can go ahead and test if it's working. There is a nice tool called Postman. You can find it on postman.com. It's a tool to test REST APIs. And what you see here on the left-hand side is simply Postman firing a first API query to interface against your router. So on one hand, set the query, set the authentication parameters, that is basic authentication, and the credentials that you did set on your router, and then you will see some JSON output. Right here, this will be one JSON block per interface, and you will see all the attributes that you know from Winbox or the CLI, like the default name of the interface, or if it's disabled, and so on. So you see, you don't have to be a programmer to do some basic REST stuff with MikroTik. Now we go ahead and set up TR069. It's called the CPE WAN Management Protocol. As I said, it's there to monitor, but mostly to configure and patch masses of CPEs. There's an extra package needed within MikroTik, so if you want to use TR069, install that package. And keep in mind that MikroTik's data model today does not support Wi-Fi 6 AX standard, so you cannot use TR069 attributes to configure AX-based devices, or at least the Wi-Fi part of it. There's something else that's special. MikroTik is not listening to DHCP option 43. Most vendors will accept an ACS URL by DHCP option 43 to allow zero-touch configuration. And if you want to achieve that with MikroTik, we have to install an additional script. And that's what we see here. Two possible options of configuring TR069 for your device. On the left-hand side, on the very left, you see the client that you need the extra package to be installed. The middle screenshot shows you how to configure the ACS manually, enable TR069, and give an ACS URL. And on the right-hand side, you can see the DHCP option 43 approach. That is, for example, if you want to ship your CPEs to different locations and have different ACS servers there with different URLs, you want to provide the URL by DHCP. And since MikroTik doesn't listen to this option, you have to install this little script in the DHCP client. The script will find the option, enable TR069, and set the URL based on DHCP option 43. And here, if you've never seen it, it's just a small part of the MikroTik data model for TR069. As you can see, it's simply named attributes like device IP interface, interface number, which can have a status and certain values for that status. Now, as said, we need two external tools, an NMS system, and we could speak about NMS for days. We simply choose Zabbix because of its great possibilities to do visualization and integrate MikroTik's REST API. Installation is straightforward. Go to the website. It's perfectly documented there, so you will get that working. And we need an ACS, an auto-configuration server. There are quite a few commercial products available, but there is also one open source solution that is still maintained. That's called Genie ACS. Most of the commercial solutions are paid for by client by month, and that's something ISPs typically don't prefer if they have an option. So we go ahead and we'll use Genie. On the right-hand side, you can see a first screenshot, but we will see more of it during the presentation. So now we got our setting, all that we will need. Now let's have a look at the cool stuff, a few examples. What will all this do for you? How will it enhance your MikroTik network or your MikroTik experience? The first example is not really referring to large networks, but it's such a great example on how to use Zabbix with the REST API that I really want to show it here. It's a Capsman dashboard. It will help you to visualize your Wi-Fi controller. And honestly, I believe many of you have been jealous about third-party vendors or competing vendors with their beautiful something, and we're there with Winbox. Winbox is great, we love it, but feels like we're missing something. So most competing vendors are offering a graphical user interface. And why would you want it? There is one reason, and it's really a pre-sales reason. It will make the CEO of your customer happy. He needs something colorful to decide for, or maybe somebody else in the company, whoever is signing the contract, but is not very close to technical stuff, he will need something colorful. But there are better reasons for that. A good visualization will help first level support greatly detecting problems. And even more important, it will give you real in-depth information to optimize your Wi-Fi network. And that's what we will see during the next couple of slides. We will need SNMP, REST, and the SABIX NMS to do so. If you could have any dashboard for your capsman that you could imagine of, what elements would you like to have there? Definitely a drill down of number of clients and bandwidth by frequency band, by SSID, maybe by access point. And you would probably want to have some elements for optimizing your network, seeing the worst clients, the most crowded access points. All this stuff is available by Winbox, of course, but not at a glance. You have to dig for it. And a dashboard will give it you right away. This is the disclaimer. These are, it's not mine, great. This is the disclaimer. Don't use that on your 1000 access point caps manager. It will not perform very good. You can use it on like 30, 50 access points, no worries. On really large installations, you have to take special precaution on what you do to be performing very good. As I initially said, MikroTik is not offering an extensive MIP for SNMP, especially not when it comes to Caps Manager, especially not when it comes to the newest version of Caps Manager. So we will definitely need REST. It's mandatory to get the information out of MikroTik that we want to have. A short introduction of SABIX. The most basic elements here are hosts and item. A host is simply a device to monitor, and an item is a value on that device that you want to monitor. Here, for example, we see an old router board 2011 in our SABIX lab, and below a few items on that router board that we are monitoring. And these items, they have different types: simple checks for ICMP, HTTP for the REST API, or SNMP for standard SNMP values. SNMP is straightforward with SABIX, so let's have a look on how to integrate MikroTik's REST API. Here you can see how to set up an item to monitor on a MikroTik host by REST. You need to set the correct type. It's HTTP agent, since we will send an HTTP or we will open an HTTP URL. You have to give the right type of information. That is, what do we expect back to let SABIX understand what type of value he gets. In here, at the end of the day, in the red box on the right-hand side, you see we're looking for the version number of our router. Not very interesting, but it's just to make this example. So this is a character. Then we have to set the URL. What are we actually asking for? It's system resource. You know that from the CLI, you know that from Winbox. And it's giving you the complete JSON block on the right-hand side, which is tested by Postman. So you will get all that JSON, the complete stuff. But all we are looking for is the version number. So there's one more thing to the REST API item to do to give you what you're looking for. You have to use the SABIX pre-processing. It's a two-step pre-processing that we need here. The first step is we name the exact JSON path that we're looking for. As you've seen on the last slide on the right-hand side, this is version. So this is our JSON path. And if you do that, we will end up with unnecessary characters with square brackets and parentheses, And the second, the trim, will get rid of these characters. If you're here, simply hit the test button and you will see this window. All three steps of our item. The first one is the complete JSON that was returned. Then on the right-hand side, you can see the 2 steps of pre-processing. At first, we are limiting to the JSON path, but we still have the square brackets, and then we will trim those characters from the output, so we finally receive what you see at the bottom right, the pure version number. And this can be used for any REST item, so it's not just the version number. Now let's have a look at the potential dashboard for CAPS Manager. How could it look like and what information can it provide for you? On the top, we just have bandwidth information. The top right will, let me see, can you see? No. The top right, for example, will give us information of the aggregated bandwidth across all access points on your CAPS Manager. Over here, we just see number of access points, number of clients, number of CAPS Manager interfaces. Not very exciting so far. But it's getting more interesting if you go here. For example, this is a drill down of actively connected items per SSID. So this will show you which SSID has how many clients connected at the moment. Over here, and I like that one a lot, it will show you the distribution of clients across your frequency bands. So how many clients are connected to 5 gigahertz, the bluish, and how many are connected to 2.4, the yellow part. And this is important information because usually you will optimize your network to have 5 gigahertz only or mostly, and if there are too many 2.4 gigahertz clients, you should be alerted and change something. Then the next widgets over here, they're not picked very good because it was in our lab, but this will give you an information of which Wi-Fi standard is used by how many clients across the time. For example, the lower one is clients for 5 gigahertz AC and 5 gigahertz AX. And here at the end, you can see there are some AX clients, and all the rest of the time we had mostly AC clients. And this is also helping you to understand what's happening within your network. I just show the lower part of the dashboard because it doesn't fit on one screen. I like these elements most. Here on the left-hand side, this is just playing around. My colleague who made the dashboard, he was bored. And what he made here is he's dynamically graphing clients in your Wi-Fi network, and the distance from the center shows the receive signal of the client. So the further away this client here is graphed, the lower his TX signal is. This is like the CEO part. But the tables here, they're really useful. I like those elements most. Here you will really get information on how your network is performing. It will show you, for example, the access points with the worst average client receive signal. These are sorted, so even if you have 200 access points, you will get those 3 with the worst average client signal. And next to it, you will see the most crowded access points. So this will help you optimize your network. Why is an access point more crowded than the others? Roaming may not be working, too many clients in an area, a lack of coverage. There are reasons for it, and you can see not the reason, but you can see what's happening and you can try to make things better. And below that, you can see traffic per Wi-Fi client, so the clients with most traffic, and also clients with weakest RX signal. This could also be interesting if you're running, for example, a warehouse with hand scanners, and you see it's always the same 5 scanners in the list of bad clients, so you should do something about that. And keep in mind, if you have low RX signal, you will probably have a low SNR and a low modulation, and this will degrade the capability of your complete access point. Let's have a look on how to create such elements within SABIX. What we see here is an example on the number of access points, how to create this widget, but this time we're using a template. We're not creating this item directly for a host, but we're using a template. And using a template is wise so that you don't have to create that item for every host. For example, if you have 5 CAPS managers, you want to create a CAPS manager template once, add your items to that template, and add the template to the host. And then the item will be there automatically. So that's what we see here, a template, assign it to the host, and we have the items pop up automatically. The number of access points, as you can see here, is simply capsman remote cap print, and then we use count only. So router OS will already count the elements for us. We don't have to do that in Zabbix. And if you want to do this, there are 2, let's say, new things that we have to look at. At first, we have to see how to implement a count only on the REST API. And this is basically here the URL with a print at the end. And over here, you can see the request body you need to implement the count only on the router as API call. And there are 2 more things that you can see here. That is all the curly brackets. Since we're creating those items not for a dedicated host, but for a template, we can, for example, not name the IP address of the host here. And we have to use something called a macro. Macros are base concepts of Zabbix, and here you see 2 types of macros. Standard macros, like host.ip, which is the IP address of the host a template has been assigned to. And there are also user-defined macros. That's what you see down here with the $sign. For example, the credentials we need to access the API for a given host. And you're responsible for making the user-defined macros available. The standard macros are available by Zabbix directly. So that's all you need to create the number of access points widget. Here's another little feature of a widget of Zabbix. That is the widget which is showing the distribution between 2.4 and 5 gigahertz. And that widget is graphing 2 items per part of the widget. So simply a small feature to know about. And this is the most complex example that I want to show you. And I like that one because it's involving Zabbix magic. Zabbix magic is discovery rules, script-based pre-processing, and prototypes. This is really stuff I love of Zabbix. You've seen that we count the number of clients per SSID. And you could have done that as in the previous examples, but it would have one major drawback. If a new SSID would have been introduced on your CAPS manager, you would have to create a new item for that SSID. And that's not the type of automation that we're looking for. We want a new SSID created on CAPS manager directly leading to a new item for that SSID, so users are also being counted for the new SSID. And that's what's happening here. It's actually not that complicated. It might look complicated at the beginning, but what we use is a discovery rule. The example involves 2 REST calls. First, a REST call for the discovery rule, and the discovery rule will return a list of items, or not items, since this is a Zabbix naming, a list of rows in a table. And then we will use prototypes to create an element for each of these rows. So what's actually happening is we're having a discovery rule on the CAPS manager registration. And then we use this will return in multiple data sets, all the items in the registration. Then we use some script-based pre-processing and provide the macros that we needed. And then we implement an item prototype. A prototype means it will take all the results from discovery and create 1 item per result. And this is how we make it possible to have a new item if there is a new SSID. If there's a new SSID, we'll get a new data set, and then we will automatically create a new item for that SSID. And the item is doing another REST call to the registration, but filtered by SSID and with the count-only approach that I've shown you before. And this is a very powerful feature, which you will see in later examples. Right here, we're using item prototypes, that's the green boxes, but you could also use host prototypes. You could also dynamically create hosts, new devices, by a list that you received by a discovery rule from REST. So much for the CAPS Manager dashboard. This was the most complex example that I wanted to show you. And this one is really going to be for large networks. Point-to-point access with MikroTik switches. I don't know if you're all familiar with fiber-based access providing. There are two different types. Basically, there's PON-based networks, passive optical networks, and there are active networks, active Ethernet, point-to-point. It's basically a simple approach, one switch port per client, typically a single fiber to that client. And this might end up in quite a lot of switches. So if you have 5,000 customers, use MikroTik switches, you'll probably use 24-port switches due to the availability of a suitable product. You will end up with 200-something switches and 5,000 ports. So point-to-point service providers often have similar demands. They would like to know which switch and which port their client is connected to. They want to have an automatical monitoring of new clients, and they would like to have a visualization of their network without graphing that manually. Here are the steps we have to take. At first, we have to determine which switch and which port is the CPE connected to. We have to make this information accessible for the NMS, and finally draw or create the hosts, make the monitoring, and draw the map for those hosts. The good thing is you've seen most of what you need already. There's just one more thing to learn. Here at first is just a scheme of a typical point-to-point network. It's rather simple. You have a core router, a core switch. You have a central DHCP server, which is important for us, some distribution network in layer 2, and finally those 200 access switches connecting your 5,000 clients. And here's the general approach. The CPE will send a DHCP request to the DHCP server, and we will get our access switch to add its switch name and the switch port to the DHCP request. This is done by DHCP option 82, called the agent remote ID and the circuit ID. So once we have this information available centrally at the DHCP server, we can provide it to the NMS and then create monitoring and visualization from there. Keep in mind, we're not using scanning. We're not IP scanning or link layer or something. This is working totally different. This is working by the DHCP option 82 and by SABIC's discovery. So for the DHCP option, to make that work, you have to enable DHCP snooping on your access switch. We don't care about snooping in this example, but option 82 will not be available if you do not enable snooping. So go ahead, enable snooping, enable option 82. And since we enable snooping, we have to care for the trusted state of your ports. DHCP snooping is a mechanism to avoid unwanted DHCP servers on your network, and you have to let your switches know which ports are trusted and which are not. For now, simply use untrusted for the access ports and trusted for all up and downstream ports. That's what you see on the right-hand side. And here's the result that you will get on your DHCP server. You see three options, option 61, option 12, and option 82. We will receive information for these options in our DHCP leases table. On the very right-hand side is option 82. Option 82 is showing you the agent circuit ID, so the system identity of the switch this very client is connected to. And on the right-hand side, you see the agent remote ID. This is the port number or the port name of that switch the client is connected to. And option 61 and option 12 are simply giving you an identification of the client. So 61 and 12 are being sent by the client, and option 82 is added by the switch while the DHCP request is traveling through the switch. There's something important I forgot here. If you're using these features, you have to watch out what hardware you're using it for. It's important that your switch chip supports snooping in hardware. If it does not, your performance will be incredibly bad on that switch. But luckily, CRS3, 5, and a couple of CCRs will support snooping in hardware. So here we are back again. So now we have the information centrally available. We have an assignment of, for example, MAC address, switch name, switch port for each client. And now we can go ahead and use the same mechanisms we've been using before. We can use discovery on the DHCP leases to get all the information we need. We rework the JSON by pre-processing, and then we can use host prototypes. In the other example, we used items prototypes, but now we're using host prototypes. So for every client in the DHCP leases table, we will create one host in SABIX dynamically. So you have your customer's CPE available in the monitoring system the very moment the customer plugged in and the DHCP lease was issued. And when we do that, we add a dynamic group to those hosts that will help us to do what you see in the green box at the end. We can draw that host on a specific submap that will be the visualization part of what we wanted to achieve. And we will also add a template to this host to be a CPE, for example, so we can create all the items, the yellow items, so the host is monitored too. So from this simple process, you will end up with all your hosts in your map. You will have monitoring and you will have visualization for those hosts. And this is how it could look like. Just a simple example for a POP with 3 switches. Those switches would be drawn manually, so that's the work that is left to you in this example. But this element here, it's called a submap that would be drawn automatically, and also the traffic for the complete submap group. And once you click one of those submaps, you will get a map with all the devices connected to this switch. As you see, you can also get the device type with a neat picture. And I guess you probably cannot read the text below the devices, so it's here a little bit bigger. The text beneath the device will tell you the port and the switch the device is connected to, and so you have the complete information available automatically without a single click of yourself. The last example. So far we did just do NMS stuff, but as said, we want to do something automatic, auto-configuration, ACS. Anybody here is using PPPoE as an ISP? A few of you, okay, great. There might be bulky PPPoE processes involving sending a letter to the customer, giving him credentials he has to enter into his box. Many things that you can imagine how stuff is working, but you could do all that automatic. And that's the point here, automatic PPPoE provisioning. Having your client up and running without doing anything yourself. Well, actually, there's one task left to the service provider. We will use an ACS, an auto-configuration server in this example, and there's not much to see in an ACS, but I still wanted to give you a few screenshots. It comes with an inventory, so all the CPEs that ever connected to the ACS are listed. It has some detailed information of each CPE. Down here you can see the TR069 parameters and values of that device. In case you can't read it, here's a simple example. For device ID product class, returning the name of the CPE or the type of the CPE. And this is where the interesting stuff is happening. You can imagine an ACS, or at least Genie ACS, a bit like a firewall. There are rules defined. These are called presets. And if a rule is matching a device connection, then something is happening. This something is a provisioning rule or a provisioning script. So what you see here is a preset for a device of the manufacturer MikroTik, which comes up with a event bootstrap, and then we will fire the PPPoE script. This is just to define the logic of how an ACS works. The script is, sad but true, a JavaScript, which is configured inside Genie ACS. And here is how the process will work in reality. At first, you have to make sure you're getting your MikroTik CPE zero touchable. We've seen that before. You have to install the TR069 package, you have to enable DHCP option 43 to receive the ACS name. So you should check with your supplier if he can handle that for you. As I said, we're doing that for 10,000 of CPEs each year. So this is a practical process and not theory. In the real world, the only step that should be left to the ISP is to record the serial number, to record to which customer it is going to. That's the part of information that you have to have. For example, you can provide that to your radio server. That would be the easiest. And then you send the box to your customer, and here's the rest of the process. The customer will connect the box to his switch or to your upstream switch. The box will issue a DHCP request. It will receive the ACS URL by option 43. It will finally contact the ACS, and the ACS will check its preset to find the correct provisioning rule for that CPE. Once it did that, it has the serial number by TR069, so it can contact your radios, for example, to get the credentials for that customer. Now, it might be necessary to issue a connection request to that CPE again, since TR069 is one way. The ACS is not capable of really configuring the CPE actively. The CPE always has to connect to the ACS and ask if there's something to do for it. So we might have to issue a connection request telling the CPE, please reconnect. Then we will receive this connection and can provide the credentials to the CPE. Finally, we probably want to set a tag within the ACS. This tag could simply be something like PPPoE configuration done. We can use this tag in future provisioning rules, because if that CPE is connecting again, we want to know that it's already PPPoE connected by that tag. And that's the last thing you have to do. Now your client is online without you or your engineers touching anything. And now I have 40 seconds left, I see on that iPad. I will show you the last very short example. Now, you got your PPPoE client online automatically. So why don't we add it to our monitoring system automatically too? And this is the last process that I want to introduce to you. We've seen the blue and green stuff on the last slide. So we ended up here, the client is online. And from here, we have 4 different choices how we could add this client to our NMS dynamically. We could have the ACS send a REST call to the NMS. That way, we would have to create a host directly. Or we could use the discovery rules that I've shown you before to have SABIX ask either the ACS or the PPPoE server or the DHCP server for a list of clients, use host prototypes, and create the hosts dynamically. And if you go ahead and use discovery from DHCP, you will even get those clients in your monitoring that couldn't connect to ACS and that couldn't connect to PPPoE. So you will even have the failing clients in your NMS and could fire an alert immediately. And 42 seconds over time. Thanks for your patience. I hope you learned something.
Thank you, Patrik. Very nice presentation.
Thanks.
As technical as we like. Any question? Yes.
Okay, one observation and two questions. The observation for all known developers in here is when you're doing a REST call using basic authentication against HTTP as opposed to HTTPS, the password is in clear. You do not want to send passwords in clear. So set up your certificates on your router so you can use HTTPS so it's nice and encrypted, okay? Just watch out for that. In the examples here, he used HTTP just for simplicity. If you use that on my live network, I'd fire your ass, okay? Simple as. Second question, sorry. What about Terraform?
Sorry?
What about Terraform in terms of configuring large fleets of routers? Are you using Terraform? Have you?
No.
Okay, gotcha. That's an easy answer. Last one should be easy as well. How do you set the admin password on a MikroTik router using TR069?
That's something that we usually do for our clients during pre-provisioning. So.
Okay, so when you first slap on the TR069, you're setting the admin password on that router at that point.
Sorry?
You're setting the admin password on the router before TR069.
Before. You have to touch the routers anyway, since you need the TR069 package. So there's MikroTik's different here from other vendors, and you can do anything you like. Depending on the customer, you want to remove the individual standard passwords MikroTik is bringing, or that's quite different.
All that normal stuff, yeah. Cool, thank you.
Yes.
Very short question. As you obviously already figured out a lot of the stuff in SABIX, is there a template online that you can refer to, or you say that you can recommend, or you have one available for us that we can import in our own SABIX environment? Because you already figured a lot of things out, and I always think you can better use what's already existing than reinventing the wheel.
Well, actually, we're building the templates as we need them to be. If you have a special question, you're welcome to drop by and try to get that answered. But we have nothing available like a public template. And from my experience, there is not that one template that will do the right stuff for every customer. And at the end of the day, of course, we are trying to make our living. So we're not publishing everything we have on the website.
Any other? Yes.
Hi, Tim from Zycom. I just wondered if whether you had a love-hate relationship with Unify.
Unify, UBNT, Unify?
Well, the reason is, obviously, I mean, that looks to do a lot of what Unify does, whether you like Unify or not, the ubiquity, you know. And Unify is free and very hands-off nowadays, you know, updates are quite regular, and even the most basic engineer can look after it and support it. So I'm just wondering how you balance the input of effort to keep a Capsman and a Zabbix.
Sorry, how we?
You know, how do you balance the input of effort into keeping something maintained that's very custom versus something that's off the shelf that does similar these days?
Oh, well, actually, we invested time in that because we have fairly big projects and very often come across customers who want something accustomed to their needs. And what I showed you here is just like the outcome of many projects, and it's not a particular product or something that we are selling off the shelf. It's more an idea on what you could do with a monitoring system since most people are simply using monitoring to ping their devices to get a red or green, but there's much more you can use it for, and that was the point I wanted to make.
Any other question? No? Okay. So thank you, Patrik. And